Thank you, Samaya. I've never been called great before, so thank you very much, I guess. So I appreciate everybody being here today. I'm going to talk a little bit about more of a philosophy about how to start with sustainability and talk about, how to look at it. And I think it does a pretty good job because I know at least the next speaker is going to build off of it, and I know that the other ones will also. So they'll kind of build off of it. So I want to kind of explain it. And so right now, when we talk about sustainability, the focus is on, like if you're out there talking to agencies, it's about EPDs, it's about, what's your carbon of your concrete, how do you lower it, low CO2 mixes. I was just in a sustainability session and they were talking LC3 concretes, and all this is great. This is things we should be doing. It's important, and it will matter. But when we look at concrete pavements, and I really want to focus on concrete pavements, but I believe it's probably true for buildings also, we don't design things very well. We don't optimize them. And so what happens is they're too thick, they have bad features in them, they get rougher earlier. And so what happens is because of how we design things, we actually can increase the CO2 in those pavements. We don't optimize them to get it where we need to be. So when we optimize them, what we can do is we can improve put better features into the system, we can take thickness out of the system, and that will lower the CO2. And so we need to start thinking about that. And from an industry perspective, we're going to do everything we can, but as owners and designers and agencies, we're also saying, hey guys, look at what you're building, because it's what you build is just as important as the materials you're building it out of. So that's what we're going to do is talk about this. Now, the process to do this is you need to kind of balance performance, environmental impacts, and cost. And so you want to use all of those things, because I can usually have maybe two or out of those three. I can have something that's low CO2. It's really easy to do. Build a gravel road. Not going to perform very well. It's going to be low cost, but you're going to be doing it all the time, and it's going to actually drive up pavement vehicle interaction and other things. And so you need to balance these, and the tools that'll do this to us, one of them, and the one we use, Juan Pablo's got another one he's going to talk about, is the PaymentMe design procedure. And the reason why is because it predicts what's going to happen in our pavements. Second tool is lifecycle cost. Again, I can give you a low CO2 pavement. I can do all kinds of stuff, and I can make a pavement last hundreds of years. Most people aren't willing to pay for that pavement to last hundreds of years. They're barely willing to pay for a pavement that lasts 25 or 30 years. So we need to make sure we can afford it. And the last thing we want to use is life cycle assessment, which is the sustainability aspects of the system, the CO2 associated with it, and trying to balance those out. And so the key tool in this really came, at least for us, the way we approach it, is the PaymentMe. And this is a design tool developed by AASHTO, came out in about 2000, it was officially adopted by AASHTO in 2011, came out in about 2007, 2008, and we've been using it since that time. And it looks at all kinds of pavements, not just concrete, it's not asphalt, it looks at all kinds of different pavements, looks how they're doing. But the key thing for us is it gives this performance over the analysis period. And so we can change things and start seeing how things happen so we can get that performance. And here's a typical curve that would come out of the AASHTO for concrete. The red line is kind of that predefined distress level. How poorly do I want to let my pavement get to? What kind of level do I want it to be at? The black line is the 50% reliability, my most likely level of distress I'm going to have in this pavement. So this pavement, most likely, it's going to last about 50 years with about 12% cracked slabs. The blue line is what's called the reliability line. So that's where I added a bit of reliability to my design. And so that says kind of where it is. And what this allows you to do is it tells you kind of what the design life is, and that's how agencies use it. They say, hey, this pavement is a 32-year design payment, because that kind of tells me where I'm going to need it. You know, I'm going to hit that predefined distress level, and it also gives me the amount to repair. And that's important because it's going to tell you what you're going to be doing with it. And that's just kind of, when we look at the performance of it and what it's showing to us, is it kind of dictates how this pavement's going to perform, so we can see where it is. And so what we actually have is a bell curve. And so that pavement will actually perform a little bit better than that where I had that design life, rehab required. It's kind of when I'm going to start patching but the pavement. But it may actually last longer, and I may want to wait for whatever reason to repair it. And I can do that, but it's going to, you know, be a more extensive repair later on in the life. And so here's why this is important. Is now I can start comparing designs. You know, as pavement engineers, one of the things we have to realize is there is no right answer. For any application, I have probably 15 different designs that could work. They're going to perform a little bit better. Some may perform very well for the 50 years. Some may need rehabilitation or patching at year 20. But I can get almost 15, 16, 20 different designs to give you the service life you want. The question is, what's the best one? And so what I can do with this is I can stick these things into these different pavements into PaymentMe, and I can get performance curves, and I can start comparing those. And so I can start seeing how these are. And so does this have a, all right, can you see that? Can you see the red dot? All right. So I can start like comparing curves. So I can have one pavement here, and this is going to perform really well, but I really don't want to pay that much. And I can start doing things. And what's important, this was some designs we actually did. It was a 10-inch pavement. Here's where it was. And we started doing different types, looked at different types of sections. We went to an unbonded overlay and looked at it. This was a 10-inch unbonded overlay, but it had poor joint spacing. And we actually decreased our joint spacing, and that's a pretty good design. So it allows us to look at different features. And so we can kind of see where they're going. And a perfect example of this is a project we did. This was a concession project looking at the pavement roadway. And the one everybody was going with was this original design, and they thought it was a better design. It's a thicker pavement. It's got a stabilized base. It's going to look well. And they ran, and you know, they designed it for be a 20-year design. And they used state of Georgia's design procedure, because that's the state it was in, looked at it and said this was our design. But when we went and started looking at the performance of these things, and we ran these for 50 years, what we see, this is this original design, the cracking, it starts to kind of go up after about year 20, 25. It starts to accelerate. And the reason why is it's long joint spacing. We have trucks. We have the front wheel sitting on the front of the slab, the back wheel sitting on the back of the slab, and all of a sudden you have top-down cracking. Environmental stresses start to drive the design more than the loads. So we changed it, decreased our joint spacing. That allowed us to get rid of the base, lower the cost, widen the shoulders, or widen the lane a little bit. And so we were able to actually get much better performance, about the same performance on IRI, much better performance in cracking, because we knew what we needed to address. We were able to look at the designs and say, hey, my problem is top-down cracking. I need to change how that happens, and I was able to look at it. And so that's what's important about it. Concrete pavement is what I like to call a creature of it's a creature of features. It depends on what you build in this roadway, how you build it, and what it is. And so these are some of the things that are really important to designs. My favorite, and Juan Pablo is going to get up and even go a little bit further on it, is talk about short joint spacing. Everybody wants to build 15-foot joint spacing. You know what? It's one of my goals in life to get that changed. I would like to see us, I like 13-foot joint spacing. Why? Because I like 13-foot wide outside lanes. Why do I like 13-foot wide outside lanes? Because I shift the load a little bit into the middle. I get an interior loading. And now with 13 by 13, I'm square. Concrete likes to be square. It's easy. They like it too. And it's a number you can kind of tell people on the construction side. Everything needs to be 13. Okay, you know, they got their number. They're good with this. But some of the other things, dowels. Again, I still see a lot of states using 1-inch dowels. I see it a lot in private work. we need to be at least a 1 1/4 inch, and a lot of times 1 1/2 inch. Another thing I like, especially on thinner pavements, plate dowels. Those are types of things. What they do is they spread the load out over where the concrete, so you don't crush the concrete. They perform much better. Tied shoulders, optimize aggregate gradations. Pulling cement out of a mix can really help sustainability. It can help strength. It can help workability. If you do it right, you know, there's ways to do it. You can't just pull out cement and get it. You have to know what you're doing and figure it out, but it's not that difficult, and we need to address it, especially if we're dealing with sustainability. Different mixes. You see some of this, especially in Europe, they use different mixes, like 2-layer construction, base types, and you get down into single saw cuts. It's quieter. You don't hear thumpity-thumpity-thump. It's a quieter pavement. Longitudinal tining. There's things you can do through the system. So that's what you want to do with design. But here's one important. This is how we actually start looking at and figuring out what the optimization is. Currently, designs are done what I call in a static mode. And so that's where I have a pavement, I need to design it. I go through some type of design process, figure out if it's adequate performance, yes or no. Once I figure it out, I go and apply a life cycle bill of activities. I say, you know, state of Georgia, I picked on Georgia already once. State of Georgia says, I'm going to do this at year 20, I'm going to do this at year 30, I'm going to do this at year 40, and it's the same stuff for every pavement, whether it's an 8-inch pavement or 12-inch pavement. Interstates, low volume road, they apply the same life cycle bill of activities. That's not very realistic. And then they come up with their LCA, or their life cycle cost analysis. What we need to do is change how we do our process. And what we do is we go through with these ME design principles, we look at what's actually happening in the pavement, and from that performance of the pavement, we figure, hey, at year 32, that's when I'm going to need to do something. What am I going to do? I'm going to do patching based on that performance graph, and I can figure it out, and then I evaluate it down here in the life cycle cost analysis or life cycle assessment and say, is this what I want? Yes or no. And if it's not, I go reiterate it. And as I go through this feedback loop, all of a sudden I can start finding things and places to save. Save money, save CO2, improve performance by putting all these things together. And it's that iterative process that actually allows us to do some good things. So here's an example of what can be done. This was actually a project we looked at with the MIT Concrete Sustainability Hub. It was a Caltrans project. This was not sponsored by Caltrans. The student working at it at the time, his dad worked for Caltrans. This was his dad's project. And he said, Dad, I need a project. And he gave this kid the work he did. So we optimized the project using this. So here was the original Caltrans design, 9.6 inches, lean concrete base, 7.2 aggregate base. And these are just standard designs. This is what's going to be in every Caltrans design out there. This is supposed to be a 20-year design. Here's all the patching that goes with it. If you look at the life cycle cost analysis and the life cycle assessment, we kind of looked at it. This project went asphalt. It makes a lot of sense. 2.2 million versus 3.1 million, 3.2 million. Even over the life cycle, concrete was way much higher. You know, Caltrans made from this perspective, a good design decision. Here's what the CO2 was, 3.9 million, 3.9 thousand tons of CO2, excuse me. You can see what was in it, 6,000 over the 6,800 over the life of the project, where you're going to go into it. So that's kind of what the CO2 was. But when we started analyzing and looking at this, and we go, wow, this pavement is over-designed. So we stuck this into PaymentMe, ran the performance for 50 years. You can kind of see these were the levels that Caltrans set. Typically, you want that line coming up, getting close to the red line to tell you how well your performance. These are supposed to be 20-year designs. These are well over 50-year designs. Now, that's not bad if you're willing to pay for it. But if you're not willing to pay for it, and they obviously weren't willing to pay for it, it's not a good design. And so there's better things to do with it. So we said, what can we do? So we started looking at ways to optimize the designs. We lowered thickness. We removed the lean concrete base. This was a 35-mile-an-hour suburban road, mainly cars. It didn't need a lean concrete base underneath it. It was just too much for it. And it accounted for 20% of the global warming potential. So we went through these, looked at all the different performances, kind of lined up the curves here where they are. Here was the original one. It's purple. Started trying different, bases, lean concrete, different thicknesses. In fact, the 8 inches over 6-inch aggregate base easily met the 20-year design. For the optimization, we looked at it and said, what's a better one is this 8.5. It's going to last a little bit long. It's going to last a lot longer. You're going to pay just a little bit more in material prices, because that's all you're paying for at this point. It's just a little bit of material. It's the same labor and everything else. And you're going to get an extra 15, 16, 17 years out of this pavement. That was the one we chose. And when you look at it, what you find out is we lowered our initial CO2 by quite a bit. We lowered our initial costs, and I want to go back to that. 2.278, that was what the asphalt was. 2.256. All of a sudden, concrete can compete. Now, if you want to really compete, you could put them head-to-head, alternate design, alternate bids, and you could compete them against. But we were able to lower our CO2. We were able to lower our cost of this project. We optimized the entire life cycle. Now what do? Now you also start asking people for EPDs. And you say, hey, I want to know what CO2 can you give me in my concrete mix. And once I have the right design, I'm starting off with 3,000 tons of CO2. Now I'm asking them to give me better concrete, optimize my mix, use my EPDs, use my SCMs, use my LC3 concrete that I just heard about. All of a sudden I can drive this even lower. Then you put that against everybody else out in their market. That's how you do it. But it takes that initial design to begin with. That's where you need to start with. So, kind of what I want to talk about is, yes, the focus on sustainability and EPDs and low carbon concrete, it's the right thing to do. My company's committed to net zero concrete by 2050. The industry is committed to net zero concrete by 2050. We are looking at it. There is so much of it is happening at this conference. Need to learn about it. However, we also need to drive home the message. It's not just what you build out of, but what you build. And we need to get agencies and owners and everybody else online with it. I've heard about, hey, Amazon wants to do all this stuff with us. Amazon's great. They're going to say, hey, we want to lower concrete. The problem is they build 5, 10 buildings, and that's not enough volume for us to change a lot of the stuff we want to do as an industry. We need to get Caltrans, Georgia DOT, all those people involved in it, the cities, the counties, everybody looking at this. Once we do that, we can recognize that it's, we have to optimize that design. We don't want to go too low. Under designing is also just as bad as over designing. If you look on the asphalt side, probably the thing that's happened more on their side from a pavement perspective is a lot of things are under designed. And they can tweak their designs just a little bit, not at a whole bunch of cost, but they're going to get a much better performance, life cycle cost, and lower CO2 also. So you can use tools like PaymentMe, life cycle cost analysis, other types of tools in this framework to help us do this trade-off analysis. And that's what's important, is figuring out what can I trade off, what can I do. And it's not just about cutting thickness, it's about optimizing the performance. So with that, thank you very much. Appreciate the opportunity to be here. And if you have any questions, I'd be happy to answer them.